Chapter 7, Polynomial Equations and Factoring. 7.1 is adding and subtracting polynomials. Okay, so a polynomial, this isn't exactly a definition, but it'll rule out some things that are not polynomials. So you can't have variables in exponents for polynomials. So no variables in the exponents, no variables in the denominators of fractions, so the bottoms of fractions, and you don't want any variables inside of a radical. So all three of these blanks are going to be variables. Okay. So just some examples. If I scroll out a little bit, when I get down here, these are all polynomials. They're basically clusters of variables and sometimes numbers and exponents, but it has to fall in these into these categories too, where it doesn't have variables in any of those positions. Okay, so a monomial is going to be a polynomial with one term. Okay, so these ones down here are all monomials at the bottom of the screen there, because it's one cluster of, so there's no plus or minus signs on these. Okay, a binomial is going to have two terms, just like a bicycle has two tires. Okay, so a monomial might look like this, or like that, or that, right? Just making up some monomials. A binomial might look like this. 2x plus 3 would be a binomial, or 5x minus 1, something like that. So the terms are the little clusters, right? And the terms are separated by a plus or a minus sign. So a trinomial is going to have three terms. So it might look x plus, well, I'll say x squared plus 2x plus 3. That would be an example of a trinomial. Okay, those are really the only three names you need to know. Of course, you can have more than three terms. If you have a 4-term polynomial, you can just call it a 4-term polynomial. Or if you have a 17-term one, you can just call it a 17-term one. But you definitely need to know monomial, binomial, trinomial. So, you know, bicycle has 2 tires, tricycle has 3 tires, right? Okay. The degree of a monomial is going to be the sum of the exponents of the variables. Okay, so looking at this example, we're going to find the degree of these. So this is x to the 7th, so my only exponent right there is the 7, so that means that this is 7th degree. Okay, for b, I'm only interested in exponents attached to variables, so that's the only one I'm dealing with there. So this one's 3rd degree. Okay, this one there's 2 different exponents, so I need to take them both into account. So I've got the 2 and the 3. So what I want to do with those is add them together, and so this is going to be a 5th degree monomial. Okay, and this last one's a little tricky. It's tempting to use the 2 that's attached to the 3, but I'm only looking at exponents of variables. This is only for the variables, okay? So this is attached to the z, this is attached to the 3, and it's really x to the 1st. The 1st isn't written because you can see there's one x, but it is x to the 1st power. So I want to use those 3 numbers. I'm not going to use that first 2 because this is, you could rewrite 3 to the 2nd as 9. You could write it without an exponent, right? So I'm going to be adding 1 and 3 and 2 together, which is going to give me 6. So that means that this one is going to be 6th degree. Okay? So that's for the degree of a monomial. It's a little different and it can be a little confusing when you're looking for the degree of a polynomial. So the degree of a polynomial can be any of these things. Monomial, binomial, trinomial. It could have more than 3 terms. Those are all polynomials. But the degree is going to be the same as the degree of the term with the highest degree. Okay, so looking at this trinomial here, I've got these 3 different terms, and I want to find the degree of each of those. So this one is 7th degree, right? And then this middle term is going to be 2nd degree. And this last one, since there's no variable, it's actually going to be 0th degree. Because you could write an x to the 0th after the 9. X to the 0th equals 1. So if it's just a number, a constant, it's considered 0th degree. And then I just look for the highest degree term out of those, which is this one. So that means that this whole polynomial is 7th degree. So I'm not adding these together. You only do that when you're working within one term, like I am up here. But these are multiple terms, right? So then you just find the highest degree term, and that's the degree of the whole polynomial. Okay. So looking at this one, it's tempting to look at this and say, oh, 5's the highest exponent, so this is 5th degree. But that's actually incorrect. This first term is 5th degree, but remember in this middle term here, I got to add the 3 and the 4 together. So this piece is 7th degree, and then this would be 0th again. And then I choose the highest degree one, which isn't always at the beginning. It could be anywhere. So this is a 7th degree polynomial, not a 5th degree one. Okay. All right, let's look at naming polynomials. There's different ways to name them. One way to name them is by their degree. So a 0th degree polynomial would just be a number. Like it could be the number 8. Because I could think, okay, that's 8 times x to the 0th. X to the 0th equals 1. So that means, yeah, just 8, right? So I'll just erase that so it's not confusing. But any just plain number. So that's going to be called a constant. A constant is a number with no variable. So it could be 1, 2, 3, 4, 5, 6, 7. It could be a decimal too, and it could be negative. But there's no x's or y's or anything like that. Okay. An example of a first degree polynomial, it would look like this. Okay, and I'm just doing these with monomials. I'm just doing one term, but you could do more than one term. So I've got 8x here because it's 8x to the first. And so this is called linear. And the reason why is because if you were to graph y equals 8x, it would be a straight line. Okay. And then second degree, maybe we'd have something like this, 3x squared. Okay, and if you graphed y equals 3x squared, it's going to be a parabola. It's going to be quadratic. So this one's called quadratic. Okay, and then if you have something to the third term, then we're going to get, this is going to be a cubic function. Okay, so if you have something cubed, that's raised to the third power. Okay, and then fourth power, like that. This is going to be quartic. I almost said quadratic. Quartic. So think of a quarter. There's 4 quarters in a dollar, right? And then so this is raised to the 4th degree. Okay. And quintic is going to be if we have something to the 5th power. Okay, and any of these with the exception of the top one, I could add in more terms. Maybe you have an x to the 2nd or something like that, right? But this is still be 5th degree polynomial because that first term is raised to the 5th. So this one's quintic. If you think about twins, except there's 5 of them, that would be quints. All right, so quintic is for 5. These are the ones you really need to know. There are names for higher degree polynomials, but you don't really need to know them. So let's say we had something to the 6th power. We could just call that 6th degree. Okay, because we don't want to spend the rest of our lives memorizing these terms. So if you have a 99th degree one, you'll just call it a 99th degree polynomial. But you do need to know these. These are the ones that are common and show up often in math books. Okay. All right, so let's name these polynomials in 2 ways. We're going to name them now by the degree and by the number of terms. Okay, so the degree of this one, this is 4th degree. Okay, and then the number of terms, I'm just counting up the clusters. There's 3 terms, but I want to use the special vocabulary. So 4th degree is going to be quartic, and then 3 terms is trinomial. So this would be a quartic trinomial. Okay, and then let's find the degree here. Okay, so looking at the degree of this, it's tempting to say, oh, 2 plus 2 plus 3, so that would be 7. But we don't want to use that first 2 because this is 7 to the 2nd is just 49. We only want to use the exponents that are attached to variables. So this is 5th degree, this part. This part would be 4th degree. So that means this whole thing is going to be 5th degree. Okay, and then there's two terms, right? This term and that term. Okay, so fifth degree is quintic. And then since there's two terms, that's a binomial. So this is a quintic binomial. Okay. Typically you put the degree first, then the number of terms. So you wouldn't say a binomial quintic because binomial's a noun and quintic is an adjective. At least when it's written like this. Okay, so standard form for polynomials, terms are arranged by descending order of degree. Okay, so let's write this polynomial in standard form. So what I want to do is find the degree of each of these terms. That first one's second degree because the 2. Then I've got third degree, and then this would be 0th degree. Okay, so then I just put them, I put the highest degree term out front. So that would be 4x to the third, and then 2x squared, and then the negative 6 is the lowest degree one. So this is standard form. It's possible sometimes when there's multiple variables that you'll get certain terms that are tied, and then don't worry about it. But always put the highest degree ones in front and the lowest degree ones in back, and get them in descending order going down in terms of degrees. Don't worry about ties though, okay? Okay, let's do some adding and subtracting of polynomials, because that's what the name of the section is, right? So first we're going to rewrite the, when we're doing this, we're going to rewrite the polynomials without parentheses. So when you're, here I'm adding two trinomials together, right? So this is actually going to look the same without parentheses, since we're just adding these two pieces together, because I'm going to be adding all three of these terms in the second trinomial. So it looks exactly the same without parentheses. And then what I want to do is combine the like terms. So I'm looking for the second degree terms, which would be these two. Those are like terms, okay? So I'm going to combine those. 4x squared plus 5x squared would be 9x squared. Got 4 of those plus 5 of those, okay? And so I went with the highest degree terms first, and then I'm going to look for, I got second degree terms. Let's look for first degree terms. I'm going to put a box around these just to group them. So those are like terms. I can do negative 3x plus 6x. Well, negative 3 plus 6 is positive 3, so this would be positive 3x. Okay, and then the 2 and the negative 3 also combine. So 2 minus 3 is negative 1. So there, I've added those two trinomials together, combined like terms, and typically you put it in standard form, so highest degree term out front. If you had it in a different order, you'd want it in this order in your final answer. Okay? So usually I actually don't write this without parentheses if it's addition. Okay? If it's subtraction, like the problems at the bottom of this page are, then it's a different story. But I just start combining like terms. So I'm looking, okay, these are like terms, they're third degree, so 3x squared plus 3x to the third plus 5x to the third is 8x to the third. Okay, and I'll put a box around the squared terms. I'm going to be adding these together, so 8x squared plus negative x squared, that's the same as 8x squared minus x squared, that would be 7x squared. And then here I'll underline the x to the firsts. So I've got negative x and positive 2x. That would be positive 1x, or just plus x. And then I got negative 4 and negative 7 gives me negative 11. Then I'm double checking my answer and make sure the highest degree is up front, and it goes down in degree till the lowest degree ones at the end. So it's in standard form. Okay. Now, when we're getting to these ones where we're subtracting, when you write this without parentheses, you're going to need to distribute the negative into the second trinomial or second polynomial, however many terms there are, because we're going to be subtracting all three of these things. So if you just write this without parentheses, but it looks exactly the same, well, yeah, you'd be subtracting the 3x squared, but then you're not subtracting this. It would be adding the 7x. But we actually want to subtract that 7x, and we want to subtract the negative 1. So what's going to happen when we're subtracting, you're going to change the sign of everything in the second polynomial, because we're going to be taking the opposite of all three of those since we're subtracting them. So this would be negative 7x here and positive 1 at the end. Okay, and once I got it written like that, then I can start combining the like terms. So I'll start with those squared terms. They're the highest degree ones. That would be 2x squared. If you have 5x squared minus 3x squared, I'll put a box around the x to the firsts. So negative 2x minus 7x is negative 9x. And then 3 and 1 gives us 4. And that's in the right order already. Okay? Here, so let's try another here. Again, when you're subtracting, make sure to distribute the negative into the second parentheses. The first polynomial can just write exactly how it is, but then we're going to change the sign of these. So negative 1 times negative 5 is positive 5. And this is going to become negative 4x to the third and positive 5x squared. Okay, so I'm looking for the highest degree terms here, just scanning through. The x to the third ones are the highest degrees, so I'm going to put, I just kind of like to put it in standard form as I go, so I'm going to combine those first to get 3x to the third. That one's going to go out front. Then I've got my squared terms, which are those two, so 2x squared and 5x squared is 7x squared. Okay, and then I've got my x to the first. Well, there's only one of those, so there's nothing to combine it with. It's just negative 9x, and then I'll combine the negative 3 and the 5 to get positive 2. And then it's already in the right order there. Okay. All right, that's the end of the section, and I'll see you next time.